So here is where we left off. We left off by asking, where did the moon come from? Where did the moon come from? Well, our current theory is that a long time ago, a massive object smashed into the Earth. Right when the Earth was being formed, when it was still partly molten and kind of in its primordial form. So here's what we believe. Scientists believe around 4.5 billion years ago. And the Earth is only around 4.5 billion years, so we figure this was right near its start. You okay, Josh? A while ago. A Mars-sized object slammed into the Earth. And when it did that, breaking off large pieces of both of the planets. Ricocheting them, scattering them into space in this massive cloud of debris. And these pieces ended up orbiting the Earth. Not all of them. Some of them never got shot up high enough to escape Earth's gravitational field. They came crashing back down. Probably some of them just continued on into space and kept going, but there was enough of them that arrived at a stable orbit, and then slowly they glommed together and became, because their own gravity acted on each other, and they formed the moon. We watched a wonderful video last class, well, before the test, the day before the test, that was made by some students. This is the impact, or the giant impact theory. It's not perfect. It explains a lot, but not everything. We're still working out the details. You can see lots of detail on the moon with just a pair of binoculars. And so, once again, I ask, who has looked at the moon through a pair of binoculars? Couple of you now. Before I told you to, or just recently?
Recently.
It's pretty spectacular when you look, you can see way more, yes? Say, I want you to nod and look enthusiastic. Help me sell it, Brian. Say, wow, yeah! Huh? Yeah, good. Wow, thank you for such a massive adjective there. So it turns out, if you look at the moon, light areas are older and highly cratered. Dark areas we feel are newer and flatter. We think that they are formed by ancient lava flows. Now, by newer and older, Jaden, both of these are really, really old. Like newer relatively, a few billion years newer, but still old. Okay? Craters are due to collisions with what? Asteroids, or if they're smaller, meteoroids. Why are there so many craters on the moon versus the Earth? Doesn't the Earth also get hit by stuff? What's the difference? Okay, so a lot of the rocks on the Earth burn up in the atmosphere. The ones that do make it to the ground, though, Cole, do form craters. Why don't we, over billions of years, shouldn't we have craters all over the place? Why does a crater on the moon stay there? Why doesn't a crater on the Earth stay there? So, lots of craters. Cole, you were right on the first part, no atmosphere. And then I wrote here, once a crater forms, it stays there as there is no moving, what word could I put there? Something that we have moving on the Earth that makes sure that things on ground get leveled off over time. Do you mind if I abbreviate? I tend to abbreviate. What else do we have on the Earth that moves that you take for granted? Not just water, but yeah. So wind and water erode our craters. None of that on the moon. In fact, Matt, we believe that the astronauts' footprints are probably still there from 1969 and 1970 and 1971. All those years later, we have a feeling if you landed there, you'd still see their footprints quite plainly because there's no wind or debris or water to wear them away. Is that okay?
I don't have
You don't have that here? So when you went to go look for your notes, you couldn't find one? Photo by our own Sierra. That's a spectacular photo. There, you've been published. The moon. If you look at it through binoculars, you'll see dozens and dozens and dozens of little craters down here. The bottom of the moon, relative to us in particular, you'll suddenly see way more detail, and you'll be, wow, that's really, really cratered. We see sunlight reflecting off the moon from different angles. And Mason, that's what gives us the changing appearance of the moon. This changing appearance is called the moons. Anybody know what we call the different way the moon looks? Begins with the letter P, H. I heard it. Someone said it. Okay. A, S. Call them moon's phases. If I was the mean teacher, I'd make you memorize waning gibbous and waning crescent, and you know what? I'm not going to make you memorize all that. But hey, keep your eyes open. Watch the moon as it goes from full moon to new moon to full moon again. It's nice to look up and see that. So what are the main effects that the moon has on us? Well, the first one, hey, I can even type this one. Calendar. 1 month is roughly one lunar cycle, not a coincidence. It's pretty close, Matt. 28 days is the moon's lunar cycle. Calendar months have about 30. I went on my rant, I think, about how we really should have 13 months of 28 days, and we'd have one extra day, and that would be our New Year's, have a big party, be great, and that way, you know, June 4th would always be on the same day of the week, which on one hand would be weird, but boy, it'd be handy. Companies would like that, because then every month would be the same length of time, which means when you're comparing your sales from 1 month to 1 month to 1 month, the comparison is valid. Now, comparing your sales, for example, in a month with 31 days to February and a month with 28 days, you have to run it through a formula and an algorithm and kind of, okay, now I can compare. What word goes in the next blank? The water on Earth is attracted to the moon. This creates, high and low tides. Sunday afternoon, I was walking in downtown Vancouver by the seawall, noticing that the ocean tides were occurring. What else? Put your pencils down. How do seasons work? I asked you guys a couple of classes ago, I said the Earth moves around the sun in an orbit that's elliptical, that's kind of egg-shaped. And I said to you, when do you think it's closest to the sun? And you all said, summer. Actually, it's furthest from the sun in summer, in the northern hemisphere. It's closest to the sun in winter in the northern hemisphere. How close or how far away you are from the sun is not what gives us summer and winter. And this is going to be on your Chapter 12 test. This is the one thing I want you to come out of here understanding. How the heck do seasons work? Because even when I talk to adults, often they'll tell me, summertime we're closer to the sun. Wintertime we're farther from the sun. No, I say no. Put your pencils down. So let's summarize for our actual notes. The Earth's axis is tilted around 23.5 degrees from vertical. Because of this, light from the sun hits the Earth at different, I'm looking for a word that begins with the letter A. Angles. During the Earth's annual journey around the sun during the year. So I have here in blank, the northern hemisphere is tilted blank from the sun, and the southern hemisphere experiences summer. So if the southern hemisphere experiences summer, what are we experiencing? So in winter, and is that because that we're tilted toward the sun, or we're tilted away from the sun? Away from the sun. In blank, the northern hemisphere is tilted blank the sun, and the southern hemisphere experiences winter. When do the southern hemisphere experience winter? When we experience, not that far away from us. Are we tilted towards or away from the sun? Yep. Near the blank, the sun hits more or less directly all year long. Where does the sun hit more or less directly all year long? The equator. I have stood on the equator with one foot in the left, on my left foot in the northern hemisphere, my right foot in the southern hemisphere. I have a little t-shirt and a little picture of me. That's why it's blank year-round. What's the temperature year-round in the tropics in the equator? Hot. Hey, let's fill in the seasons. Which of these would be summer for us? 1, 2, 3, or 4? Yeah? Which of these would be winter for us? And then I had to tell you which way the Earth is moving. So here is summer, blah, 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 blah. Mystery season, blah, 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 blah. Winter. What comes between summer and winter? Or autumn. Fall's easier to write. So what's number 1 up there? So if someone says to you that summertime is when the Earth is closer to the sun, you can say, actually, no, it's furthest from the sun. Do you know why we have summer? I'm looking for one word, begins with a T, ends in a T, has an I and an L in the middle of it. Tilt. So, solstices, some terminology here. In the northern hemisphere, the summer solstice is the longest day of the year. Usually occurs around when? Around June 21st, plus or minus a couple of days. Josh, you gonna make it? In the northern hemisphere, the winter solstice is the shortest day of the year. Usually occurs around December 21st. In the far northern latitudes, above 66 degrees, what we call the Arctic Circle, it's even more extreme. So above 66 degrees, the Earth is tilted towards the sun enough that during the summer solstice, the sun never goes below the horizon. And during the winter solstice, the sun never rises. That's why the northern hemisphere, the Arctic Circle, is often nicknamed Land of the Midnight Sun. You'll have it section of time where the sun never sets. Eclipses. There's going to be an eclipse August 21st next year in Oregon. I think I'm going to do a road trip. So let's talk about those. What's an eclipse? Every so often, the moon will cross between the Earth and the sun, blocking the sun's light and casting a shadow across the Earth. We call this a solar eclipse. And I have a diagram there, yeah, with like blanks. I'm going to give you this same diagram on your test, so you can label it. These are words I'm going to ask you to know. Sun, the moon, yeah. Earth, yeah. And then we have an area called the umbra. That area would get complete darkness, Ibrahim, during the solar eclipse. And then there's the penumbra. That area would get twilight-y during the solar eclipse. And then here, nobody would notice anything. They'd still see the full sun. So you'd have a partial eclipse or a full eclipse. Umbra, penumbra, sun, moon, and earth. Is that okay? Got him, Kev? Then there's another type of eclipse. In a lunar eclipse, the Earth goes between the sun and the moon. And the moon becomes blacked out or very reddish looking because it's lost in the Earth's shadow. Sometimes it's called a blood moon because it's very reddish looking. Do you guys have another diagram? Hey, here is a lunar eclipse. We have the sun, the earth, we have the umbra and the penumbra. If the moon was in this area here, it would look very, very reddish colored. If it's in the actual umbra, you can't see it. Really, I'm going to guess, Cole, all of you are going to be able to figure out which one's the sun, the moon, and the earth because of their sizes. Really, for the diagrams, you'll need to know the difference between penumbra and umbra. I'm not big for memorizing stuff, but it's in the curriculum. Okay. On August 21st, 2017, there's going to be a solar eclipse in Oregon, and it's going to slowly make its way across the U.S. We will get twilight or even darker conditions. I'm planning on doing a nerd road trip with some other teachers. Put your pencils down. So there's 10 minutes left. The one you want to get done for next class is the section 12.1 homework. The second sheet that I gave you, you'll have some time next class to work on it as well. We should finish off, I hope, most of chapter 12 next class, I think. Sorry? When you're done? Yeah. I'm not going to collect the Bill Nye sheet, though.